Alright, so adding and subtracting rational expressions, or equations, or anything for that matter. Rationals, remember, just mean fractions, basically. We're going to require a common denominator. So for the first one, 6m cubed n, 6m cubed n, we've got a common denominator. Then all we do is we add straight across, or subtract for this problem. So I've got m, let's just go ahead and write this out. You can skip this step if you can do it in your head, but you have to be careful to remember that that's like in parentheses, so that negative gets distributed. So it'd be minus m minus 3n over, and then the denominator does not change. Combine like terms if you can. Gone. Gives me negative 6n over 6m cubed n, and then you just have to remember to simplify. I can cancel my n's and my 6's. That does not leave m cubed. Does not leave negative m cubed. It leaves 1 over negative m cubed. So be careful that you keep that placeholder with a 1. Then the next two no longer have common denominators. So we would just go through the easiest way to get a common denominator is to multiply by the other one, which you guys have done this year. So we're going to multiply the second by x minus 1 over x minus 1, and the first by 4 over 4. That's going to give me 24, and I just leave it undistributed, at least for the time being, and then decide if we need to go ahead and distribute. Now we have a common denominator, so we can go ahead and combine them. So 24, I'm going to go ahead and distribute minus 5x squared plus 5x over 4x minus 1. You would want to make sure that this cannot factor, and since they are large numbers, you can't do a GCF. I went ahead and did the quadratic on it to see if it was factorable. If you do the quadratic and you get two whole numbers, that means it was easily factored. When I did the quadratic on the numerator, we got decimals. That tells me that that's as simplified as we can take it. If it was factorable, there's a good chance one of the factors might be x minus 1, and it could cancel like we did up here. But since it's not factorable, final answer is right here. Then the last one, let's get it back in focus. You obviously want to check to make sure that nothing can simplify before you move forward. So over here, everything is divisible by 2. So I'm going to go ahead and simplify this. The first fraction is going to stay. I'm going to take a 2 out of everything. So that's going to leave 2n over n plus 3. Now that didn't really get us to a common denominator, but it simplified for us. So then we'll multiply the first by n plus 3 over n plus 3. We can't just multiply by 3. And then the second by n plus 5 over n plus 5. It's going to leave 5 n plus 3. I'm going to go ahead and distribute over 2n n plus 5. My common denominator is n plus 3, n plus 5. I will go ahead and get these simplified, so 5n plus 15 plus 2n squared plus 10n, and I'm going to go ahead and tell you I did do the quadratic on this one again to make sure that it was not factorable. Go ahead and write it in standard form. And because I did the quadratic on the numerator and got decimals, that tells me that we're done. We can't simplify any further.